My name is Mark Bigland-Pritchard. I am an energy consultant and applied physicist. Well, this is about how do we shift to renewable electricity well before 2050. 2050 is more or less the date that, according to the 1.5 report that's just come out from the IPCC, we need to have our economy totally decarbonised. Now that's complex. There's a lot of elements to that, but electricity is one of them, and it's an important one. It's really the first one that we need to address, partly because in many ways it's easier than the others, and partly because if we can get electricity right, that enables us to get some of the others right by electrifying them. So we move to electric vehicles, we move to heat pumps to provide heating for buildings. Having done good insulation work first, we move to electricity for a lot of industrial processes which are currently using gas or diesel. So electricity is kind of central to any sort of decarbonisation programme. So what I'm doing is I'm taking hour by hour data. I have data for one sample year, which I can then adjust according to projections of how different demand sectors are going to change, right up to 2030, 2040. So I've got a standard year for each year up to that time, for each hour in the year. So 8,760 hours or 8,784 in a leap year. The point of having it hour by hour is that we need to have supply meeting demand all the time in each one of those hours, which means that there will be times when the wind isn't blowing enough, when the sun isn't shining enough, and so then we need to bring in more of the biomass or more of the hydro, or bring stuff in from storage, or bring stuff in by importing from Manitoba. So, putting all of those options into the mix. And then there'll be other hours when we've just got too much wind and too much solar, and so we have to put that into storage. So it's a matter of matching supply and demand so that we have secure electricity supply right the way through to that time, as we are making the grid more and more renewables dependent.